format, which you will do missing value imputation, you do feature scaling, you also will do some kind of one hot encoding, and once you finish that, you will also train your model, right? This cycle will run model training, tuning, ensembling, and selection. So this process will help us to select the best model. Correct? We agree, all of you?
Yes, sir.
So once you finish selecting the best model, you will try to finalize your pipeline, and then you'll deploy and monitor it. But again, during the monitor process, if you find any issue with your model performance, you will again go to this particular process again. Again, you will go and train the model, tune that, ensemble it, and you'll try to select one which is the best model again. And again, you'll finalize your pipeline and deploy it. So this cycle will be continuously running. So this is called a pipeline. So any data science project requires a pipeline, end-to-end pipeline to implement that project. Correct, right? If I talk about pipeline in the sense, every pipeline, a life cycle, as I mentioned here, business problem, data collection and sourcing, EDA, data preparation, modeling, training, deployment, monitoring. These are the steps which we discussed about. Correct? But this is a pipeline, right? Step by step. Why we call this as a pipeline? Every step depends upon the previous step. Correct? This step depends on this one, this step depends on this one, like that. Every stage depends on the previous stage. So this life cycle can be implemented using this particular set of pipeline. And this pipeline, if at all I want to implement, I need to have a separate coding I need to do, or I need to use the existing packages. So PyCaret is one of the package which is used for that. So there are many challenges for building a ML life cycle. Like since it is an iterative process, very time consuming. We don't know like how much time it will take, because data preparation only will take so much amount of time. And which are the right tools to use, and who are the right people is very, very important. And creating a streamlined pipeline without any issues is very, very difficult. And even after you create any pipeline, it is not easy to maintain that in the production. Okay, just 1 minute, guys. Just a minute. Okay, sorry guys. So creating a seamless pipeline is difficult. Even if you create it, it is not easy to manage it in production, because you need the right set of people. They should have the knowledge to maintain that. So most of the data science projects will not go into success because they don't know how to maintain that. So not only we should not only focus on the end goal, we also need to focus on the technical aspects to maintain that. If you don't think about any issues, post deployment issues, if you don't take any appropriate action in advance, you will need to experience the failures. The scalability also is one of the important, where scalability is where most of the people will experience, because most of the data may be too high and your model may not be able to manage that much amount of data. You need additional infrastructure. So that is also one of the challenge. These are all called as post deployment challenges. So where PyCaret is one of the package available, and which is very, very easy to use open source Python package and low code machine learning library, which will help us to build an end-to-end ML model management. And you can reduce your code and it will help to create your pipeline, and you use that pipeline and you can go and run your code, and it will help us to not only create the multiple models, it will help us to even select the best model among them also. Clear? Yes or no?
Yes, Srinivas.
Yeah. So whatever the project you are going to work on, PyCaret is going to help us to. It is going to help us how to go and create the end-to-end pipeline. To use PyCaret, these are all the features with PyCaret. It will automatically do all this. It will do data preparation automatically. It will do model training, hyperparameter tuning. It do experiment logging. It select the best model, and it will go and help us to even compare the models with some kind of analytics as well. You can interpret how which model is best and why it is best. You just need to feed the data. That's it. You need to just to feed the data. It will automatically identify which is the target variable, independent dependent variables, and build multiple models. And then it will go and help us to select the best model for our deployment. It also have APIs to even save the model later. Once you receive the best model, I can even save that into a pickle file or some format. So later we can use for the deployment. So as we know already, we have different supervised, unsupervised algorithms. PyCaret is supporting classification and regression as of now. It also supports all these unsupervised also. Most of our use cases will fall under these categories only, right? Yes or no? Classification, regression, clustering, or anomaly detection, or market basket analysis, and natural language processing. Only most of the projects.
Yes, sir.
So now, if I go back and see, these are the statistics we go see. Already, so many people are already using that. 5 lakh plus downloads and 3,000 plus Git users, Git stars are there, and 46 contributors are contributing to develop this core PyCaret. And so PyCaret is very popular now in the market. Okay, and it also help us to even not only CPU. I can even use PyCaret on GPU also. GPU in a sense, in a deep learning kind of applications models. So it is also helpful for distributed clusters as well. I can easily integrate PyCaret with distributed computing as well, like PySpark, all this kind of tools. So these are all the integrations which PyCaret is helping nowadays. Like I can integrate with multiple different other tools as well. So MLflow for model versioning, you can see like Cat Boost, Aptuna, Plotly, XGBoost. Most of scikit-learn, most of these packages are commonly used packages for machine learning. So you need to understand how PyCaret is going to help us to integrate with this. And coming to like PyCaret usage, right? I need to go to so PyCaret will have regression and classification. Let us try to understand about regression. What is your understand about regression? Who will tell? When I need to go for regression?
When you have a numerical data.
Very good. So my target is a numerical. My target is a numerical target. Then I will go with the regression. So PyCaret has already available, which I can go and install. So to install PyCaret, I need to use this command pip install PyCaret. So this is going to install PyCaret in my environment. You can also use this Google Colab, which is the easiest way to install PyCaret. So try to use this one. And once your PyCaret will be installed, we can go and start using it. This is a simple Python package which we need to install.
From where we should install this, sir?
So you can simply go and this is the Google Colab. It is a Google Colab notebook. You can also go and open this simply searching for Colab in your Google. Go here, search for Colab here.
Hmm.
Colab Google. You need to register with your Google account. Once you click this, it will open your Google Colab account similar to this what you can see here.
Okay.
And you need to upload the one which I'm going to share this file. I'm going to share this Python notebook. Go to file, upload.
Okay.
Once you click on upload, you need to browse and open your file, and then open means it will come here, and you can open that, and that will open like this. So once after this is installed, you can simply go and run this, and this is going to display me what is my current version of PyCaret here. 3.2.0 you can see here the latest version.
Okay.
Clear?
Okay.
So once you install this, now I can start using this. So to start with, you can use some sample data where it has PyCaret has some data sets. You can see here incident data set. I can go and you load them. So how to load that? I need to go and use from PyCaret data sets import get data. This function is going to help us to load the sample data sets from PyCaret. So you need not even go and look for any data. You can directly even pull the sample data for insurance domain. So every domain they have some data. Banking they have some data. Supply chain they have some data. Insurance somehow they have some data. So you need to find out. Okay. Now I'll assume that I want to predict the charges here. So PyCaret I want to use to predict the charges of the insurance premium. So maybe this will become my dependent variable. The rest all will be my independent variables. Correct, right? Do you agree, all of you? So what I am going to do, I am going to use these independent variables and I'm going to predict these charges. So sex will impact the insurance charges. Sometimes smoker will impact, right? If smoker yes means he will have more premium because risk is high. And based on your age also your premium will be high. So these factors will influence my charges. So you need to see how they are going to influence these charges. So I will go and load this data first. So once my data is loaded, I can see the data. This is the data which contains. I can even go and convert this into a table also. So because if I click this, it will go and convert this into a table like this. Can you see? Just like a table, it will show us, and I can even go and see maybe 100 rows also. What I want per page. So I can go back to data frame, and you can see the distributions of the data also. See. So this is to see what the data is about, and each data distribution you can see like for each categorical what is the data distribution like that. Okay, now my data is ready, which is stored in the data frame name called data. So I can use this data frame name with data, and I can start using this particular regression functions available in the PyCaret package. So I need to import all the functions of regression package, and I need to set up a session to open and then create my set of ML models. So I'm simply passing only data here. The function setup requires which is the input data, which is the target variable. We'll clearly mention here. And you are giving some session ID 1, 2, 3 randomly. You can give any number. So this is going to open a session, and it will go and create me a session with name yes, and this function is going to show me the initial data preparation. As you can see, session ID 1, 2, 3. Target is charges. Target type regression, and how many rows and columns are there, and how many features are numerical features are there, categorical features, everything you will see here. Every data preparation it will go and show us. And once after this is done, we can go and create a regression experiment and we can go and regression experiment is there. Import regression experiment from the regression module, and you need to create an object for that. And I can use, you can see the type also, it will be a picaret type regression variable object. So now I can use this one also to create my experiment. So now my experiment got created. Now what I will do, I will go and use simply, since after I run this line of code, the job of this particular setup function is to create multiple models. And this object is going to hold all the information. Now I simply go and run my function called compare models. This is going to collect this data, whatever we pass it to this model, the session data, and considering the target as a like a charges as a target variable, and it will go to build multiple models. You can see here. We are not going to write any code for like a scikit-learn. It is creating. It is automatically using the tenfold cross validation. You can see here, fitting 10 folds. And you can see it is generating multiple models. See, all regression models. Can you see everyone?
Yes.
Some algorithms you may not even know. Even I don't know, because these are all fixed by picaret. Like for example, least angle regression, lasso least angle regression. These are all very new. Passive aggressive regression. So these are all like different other algorithms, but you need not even worry about. You need to select the best regression method here. So gradient boosting regressor is having the minimum error and highest R square. You can see here. It is already sorted in the descending order of R square, correct? Yes or no?
Yes, sir.
And ascending order of MAE. So my error should be low, my R square should be high. So gradient boosting regressor is having MAE low and R square is high. So I am going to select this as my best model, gradient boosting regressor. Now I am going to go and use this, and I will try to even plot by best. I said it here best equal to. So my best model, if I go and display, so my best model will be, I display my best model. My best model will be always gradient boosting regressor. You can see automatically it identified. Now I will use this best here, and I will try to plot based on the feature importance. Plot underscore model is a function, and I am using the best model, and I am plotting that by feature importance. You can see here. So which is the important feature? First important feature here, smoker, right? So you tell me in general which of the criteria that will impact the customer's insurance premium. Who will tell? Which are the factors that will impact customer insurance premium?
Their age.
Smoker. Smoker
Yeah.
will impact, right? Body mass index will impact, right? Age, correct, right? And number of children also impact, right?
Yes, sir.
So
Yes.
that is why you will see these are all the topmost. Top is smoker, because high risk will be there with a smoker. Body mass index also they will see. And age they also matters. If age increases, premium increases. Number of children also will increase. Northeast region may be having some kind of risk, but these are all at the same level. You can see here. Only the 4 important factors you can see. These are all the variable importance for my model. So if you go with our error side, you will see nothing but the RMSE or R square. So R square is at our 88%. The best fit line is nothing but this one, the dark dash line, which is having the highest R square. So we can conclude that the best fit line is having the highest value of R square, 88%. Okay, and apart from that, we can also go and use evaluate model, because I can use the same model name, and evaluate model is going to give me, this is my pipeline. See how it has been executed. First it took raw data, and then it used a simple imputer, like as part of feature engineering, and hyperparameter validation it did, and then feature importance, and it took almost all these operations step by step, and finally it built a gradient boosting regressor. So this has been taken care by PyCaret. You do not even do anything. Everything has been taken care by PyCaret itself. And coming to prediction side, I can use my predictions. So my final model I can store in a predictive model name. I'm storing in this particular holdout pred is my name, and this is the best parameters of my gradient boosting regressor model, which is the best model. And I can go and see the data also. Simply go by selecting the top 10. So these are all the top 10 rows where you will see the predictions. See, these are the charges and this is the predicted. You can see here, right? The actual predicted. Clear, everyone? If you observe here, smoker high is having, it has been increased, the charges compared to the previous one. Compared to actual charges, my predicted charges are high because he is a smoker. And age also, if you observe, wherever age is high, you will see